Hi, hello dear students. Welcome to the class. Today we shall discuss concern to the physics problems. So let us have the first problem here that was appeared in 2017. The first member of the Balmer series of a hydrogen atom has wavelength of how much it is given? 6563 angstrom. Okay, 6563 angstrom. Then he has asked to calculate the wavelength and frequency of the second member of the same series given here, that is C is equals to 3 into 10 raised to 8 meter per second. For this problem we need to find out the whatever that what he has asked, wavelength as well as frequency concerned to the second member. Okay, first member he has given for the Balmer series, but he has asked to find out the second member. Okay, let us we shall proceed concerned to that. So let us you see here whatever the data it is given, C value it is given here, the same C value is written here, that is 3 into 10 raised to 8 meter per second. Then what the series he has mentioned in the problem you see here, that is a Balmer series that is given in the problem. So series that is given as a Balmer series. Okay, next one more data he has given in the problem, that is what first member of the Balmer series, whatever the wavelength he has given, that is what 6563 angstrom. Okay, that is wavelength of a first member that we are going to denote it by the lambda 1, that is what 6563 angstrom. That angstrom has to be converted into meters, that is 6563 into 10 raised to minus 10 meter. Okay, these are all the given data whatever it is given. And for the first member of the Balmer series, so that n1 value, so let us mention that for the Balmer series, so n1 value is 2 of course, but for the first member, so n2 value becomes as what it is 3. Okay, as we seen in a previous class concerned to the spectral series, in that we observed that concerned to the Balmer, any higher position to the where it is going to come, any higher orbit to the first orbit it is going to come out. Okay, so for the first member n1 it will be what that is 2, whereas n2 is coming as a 3. Okay, next we have the formula concerned to the wave number, that nu bar. Okay, for the first member if you would like to mention, that is nu bar 1. Okay, nu bar 1, that is equals to 1 by lambda 1, which is equals to r, okay, into 1 by n1 square minus 1 by n2 square. Okay, lambda 1 already we taken here, that lambda 1 has to be substituted, so that is 1 by 6563 into 10 raised to minus 10. Okay, which is equals to r value that we have to write as it is r. Next n1 value, that is what we have taken here 2, that 2 square. Next n2 value is taken as 3, then 3 square. So do the simplification of that, that is 1 by 4 minus 1 by 9. Okay, 2 square that is 4, 3 square that is 9, that's why that is 1 by 4 minus 1 by 9. Then if you take the LCM, that LCM it is what 36, then this 9 here, next 4 here, that is 9 minus 4, then you are going to get as what it is 5r by 36 on this side, that as it is. Okay, 1 by 6563 into 10 raised to minus 10 as it is. So after simplification you got it as what it is 5r by 36. Call this as equation number 1. Okay, call this one as a equation number 1. I hope everybody understood clearly about this much. Okay, so this is all about for the what it is first member, for the first member it is. Then we shall continue for the second member. So for the second member, n1 remains same. See here, for the second member of a Balmer series, n1 remains same, only n2 is going to get changed. So in previous case for the first member, so that n2 that is what 3. Now so n2 becomes as a 4 for the second member. Okay, in the same formula here we have taken as a nu bar 1. Okay, here nu bar 2, that is 1 by lambda 2 r into what it is going to come out again, n1 square minus 1 by n1 square minus 1 by n2 square. In the same way you substituted, that is r into 1 by 2 square minus 1 by 4 square. Okay, so 2 square it is what it is, 2 square that is a 4. Okay, 2 square that is 4, 4 square that is what a 16. So that is 1 by 4 here, 1 by 16 here. Then if you take the LCM it will be what a 16, that LCM is 16. Then here 4 and then here 1, 4 minus 1, then what it is going to come out on this side, that of course 1 by lambda 2 as it is. So here r as it is. So if you simplify that one, you are going to get as 3 by 16 into r, 3 by 16 into r, that is 3r by 16. Call this as equation number 2. So we are having two equations, and here unknown what it is, r here is also be there, r here is also be there, that is going to get cancelled, but here unknown is only that what it is, so that is lambda 2. So for that we need to divide one equation by another equation. So for simplicity point of view, so what we are going to do, dividing equation 1 by 2. Let us see here, that is dividing equation 1 by 2. Okay, dividing equation 1 by 2. So whatever the equation 1 we are having, so there, so let us see here, that is equation 1 is 1 by 63 into 10 raised to what it is, 10 raised to minus 10, 1 by, so that is 6563 into 10 raised to minus 10. So that it is written here. Okay, that is a 1 by 6563 into 10 raised to minus 10, whole divided by, that equation 2 is there as 1 by lambda 2, that is divided by 1 by lambda 2, which is equals to, so equation 1 that is there here as a 5r by 36. Next whole divided by, concerned to the equation 2 that is there as a 3r by 16. Okay, so do the simplification, what it is going to get. So reciprocal, after doing reciprocal and simplification, here you are going to get as a lambda 2 in a numerator, and denominator this 6563 into 10 raised to minus 10, which is equals to 5r by 36, that is 5r by 36 into reciprocal, if you do 16 by 3r, this r will get cancelled. So next we want lambda 2, that implies lambda 2 is equals to 5 into 16 into this cross multiplication you do, that is 6563 into 10 raised to what minus 10, whole divided by 3, that is 36 into this 3. Okay, if you do the calculation of this, then you are going to get as a what that lambda 2 as 4861.4 into 10 raised to minus 10 meter. Then this is going to convert into angstrom as a, that is lambda 2, 1 angstrom is equals to 10 raised to minus 10 meter. So that 4861.4 angstrom. Not only just he has asked about the wavelength, but also he has asked a frequency. Okay, for that frequency, so let us we shall make use that simple formula, that is wavelength, as we well known, lambda is equals to what that we known, c by nu. Okay, lambda is equals to c by nu. Here for the second member we considered, so that is lambda 2 is equals to c by nu 2. We want the frequency, so that is nu 2 is equals to c by lambda 2. Whatever the lambda 2 we got here, that has to be substituted. C value that it is given in the problem itself. Okay, that is 3 into 10 raised to 8 meter per second, that C value, and then lambda we got here, that has to be substituted here. Okay, once you substitute and simplify, you are going to get that nu 2. Okay, concerned to the nu 2 here, you are going to get as a 0.0000617 into 10 raised to 18 hertz. Okay, you express this in terms of scientific method, so then that can be expressed as just shifting this digit, okay, decimal on this side, then you are going to get as 1 2 3 4, okay, 10 raised to minus 4 into here, that is there as 10 raised to 18, okay. So that you are going to get as 10 raised to minus 4, then 10 raised to 18, then you are going to get as 6.17 into 10 raised to 14 hertz, okay. That lambda 2 is here, either it in terms of meter or else in terms of angstrom, then frequency is here, okay, for the second member of the Balmer series. I hope everybody clear about this problem. Let us move one more problem that is also be quite simple. So let us find that here. What he has asked, let us observe that one. Calculate the wave numbers and wavelength of a second line in Balmer series, okay. So here just a second member he has asked, and Rydberg constant, as we well known, that is R value. So that is what 1.097 into 10 raised to 7 per meter. That is the Rydberg constant R value. Okay, if there will be the relative lines wavelength and frequency, then that value is going to get cancelled. If not given, so at that time for the single we shall assume this one as a what it is, R value 1.097 into 10 raised to 7 per meter. Next series, it is given as a what a Balmer series again. Previously we have done concern to the second member. Let us take the same data for this also be second member of the Balmer series or second line of the Balmer series. So N1, that of course what it is 2 and N2 is 4, okay. Let us write the formula for the wave number, that is nu bar is equals to 1 by lambda R into what it is 1 by N1 square minus 1 by N2 square. R value, that standard value, it is there as what it is 1.097 into 10 raised to what it is plus 7 per meter, okay. That value has to be substituted here. Next N1 value, that is what it is 2 square, N2 value is what it is 4 square. So do the simplification, then you are going to get that as a 1 by 4 minus 1 by 16, LCM is 16, 4 minus 1, then you are going to get as 3 by 16 into this 1.097 into 10 raised to 7. If you do the simplification of that, then you are going to get as a wave number, that is what 0.20568 into 10 raised to 7 per meter, okay. Wave number unit is the per meter. Then one more he has asked, not only just wave numbers but also wavelength, okay. What is that relationship between wave number and wavelength? So see here the formula, reciprocal of that wave number, that is going to give out as a what wavelength, or else reciprocal of the wavelength, that also you are going to get as a what wave number. So just this wave number whatever we obtained here, that has to be taken as a reciprocal, then we are going to get as a what, that is concerned to the wavelength, okay. Let us see here that if you take the reciprocal of this wave number, so that is 1 by 0.20568 into 10 raised to 7. So then you are going to get wavelength as a 4.8619 into 10 raised to, if you shift this to the numerator, then 10 raised to minus 7, okay. That many meters. If you like to express it in terms of a scientific expression, let us see, can have here, that is shifting of a digit, okay. Then 1 digit, 2 digit and 3 digit you can shift, that you are going to get as 4861.9 into 10 raised to, so here already minus 7 is there, if you shift then 10 raised to minus 3 and minus 7, then it will be 10 raised to minus 10 meter. Or else if you like to express in terms of a angstrom, then that is 4861.9 angstrom, because 1 angstrom that we have, that is 10 raised to minus 10 meter, okay. I hope everybody clear about these two problems. In the similar fashion, so if this is clear, in the similar fashion in the next classes also we shall solve some of the problems, some derivations, some laws also. So you need to comment how is this class also, so that if it is useful for all of you, then we shall proceed the similar kind of online classes in YouTube. Okay, and subscribe our YouTube channel also, so that whenever we are going to upload the new videos, then you are going to get the notification. For the subscription, totally it is free of cost, no cost for the subscription. Okay, click on a subscribe button, as well as there will be the bell icon, then only you will get the notification whenever we are going to upload similar kind of classes. We shall extend for the mathematics, chemistry, biology also. Okay, so you can share this video to all of your friends also, so that they can also make use this video for their preparation. Okay, thank you to one and all. Bye bye, see you in a